Alright, there are a couple special cases when it comes to factoring, which you can factor the way we did the other one. Totally possible, but it's not a harder level question. It's actually an easier one that if you recognize the pattern, the questions go much faster. And since it's something we test you on, it's the kind of thing that when you're on the test, you look forward to seeing these problems, because if you can recognize the pattern, you're more likely to get to the right answer. So before we see how to factor squares, let's see what happens when we simplify a square. The quantity x minus 2 squared means that I'm literally going to take x minus 2 and multiply it by itself. Right? If I do that, my first times my first, I get an x squared. My outsides, negative 2, make sure everything keeps its sign, negative 2 and the x make negative 2x. The insides, again, I have a negative 2 with an x, minus 2x. Finally, I have a negative 2 times a negative 2, which is a positive 4. As always, the middle terms combine, so I have x squared, a total of negative 4x, plus 4. Alright? X squared minus 4x plus 4. Well, let's see if we recognize a pattern. How do we know by looking at this one that this is a perfect square? Again, you can do it the same way as normal. Notice that two numbers multiply to this and add up to this. The only thing that works is 2 and 2. Okay? But let's try it again and see if you notice a pattern. This time I'm going to do x plus 3 squared, which is x plus 3 times x plus 3. When we multiply that out, you get x times x is x squared. X times 3 is 3x. 3 times x is 3x. 3 times 3 is 9. For a final answer of x squared plus 6x plus 9. Notice in both of those cases, we had that middle term repeated. Right? The middle term was repeated. It was the same thing. In other words, this half was the same as this half. Let's look at either half. What's negative 2 squared? 4. Let's try this again on this one. We have this half says 3, this half says 3. What's positive 3 squared? 9. In other words, if you look at a polynomial, a second degree polynomial, if you have a middle term that's even, and if you cut it in half and then square it, and it's your last term, we had a perfect square. One more time, let's say that more slowly. If I divide this number by 2, take half of it, what's half of 6? 3. And then square that number. 3 squared is 9. Then I know this is a special case. It's the quantity x plus 3, that magic number that added up to that and multiplied to that, squared. Let's see if you can recognize that right off the bat. Say I have x squared plus 10x plus 25. The first thing we should ask ourselves, if we see a perfect square sitting at the end, is, hey, is this possibly a perfect square? As in a perfect term squared. What is the square root of 25? 5. So we have a possibility here. Since the last term is a perfect square, maybe this whole thing is the consequence of a binomial squared. Right? The way to check it, what's half of 10? 10 divided by 2 is 5. 5 squared is 25. That matches. So rather than doing our standard way of factoring, we can just say, well, heck, half of 10 is 5. 5 squared is 25. This must simply be x plus 5 squared, and we're done. This is intended to make the problem easier. You are still more than welcome to break it up like we did in part A, an x here, an x here, and think of two numbers that multiply to 25. Well, that's 25 and 1, or 5 and 5. Which of those adds up to 10? The second case, obviously. It's x plus 5, x plus 5, so our answer is x plus 5 squared. This will always work. The way we learned first always works. Always works. The point of learning the factoring squares trick is that maybe you can get an answer faster. Maybe you can recognize a pattern and see the correct answer. without having to do this step. It's just an added feature, but it's one that's necessary to learn because we're going to use this perfect square procedure, if you will, for learning how to graph more complex equations in the future.